Guys, all of you should have your assignments already turned in. If you don't have them turned in, you can turn them in by the end of the day today. There are a few of you who were missing or absent yesterday. Talk with your champ teacher and then have them call me, and you can come on back down here, finish it today, because you're just finishing up the second section. It shouldn't take you the full time to do it, because again, it's powers of I, adding, subtracting, multiplication, division, and then possibly, because if you finished part 2, I gave them back to you. Because if you started part 2, I kept it. If you didn't start part 2, you have it. Because I think both of y'all started it. Now, for the most part, most of the tests, y'all did pretty well on it. I can tell already just from looking at most of them, either A, you didn't actually fill out the review sheet, you waited to go over it with me and watch what I did, which means absolutely nothing, because you don't actually learn it. It actually has no meaning attached to it, because you didn't actually work the problem. You just copied down numbers and then hoped that it would actually mean something on the test. Because on part of them, especially the first part for completing the square, the first part in completing the square is A equal to 1. If not, make it so. Neither one of the ones on the test had a number for A other than 1. I saw several of y'all just go on and divide by 2, because that's what we did on the review sheet. But on the review sheet, the number for A was 2. So again, I give you those review sheets to help y'all. If y'all don't do them before the test and actually do them, it's not going to help you. I go over it with you to fill in gaps or answer questions, not to just give you all the step-by-step to fill in. So, we're going to go on and move on to Chapter 4. Chapter 4 is polynomial functions, and quadratics are a type of polynomial function. We have at least 2. Now, quadratics are a type of polynomial function. So ax squared plus bx plus c is a type of polynomial function. Now, there's more than just those. Any of these are considered polynomial functions. So the equations that you had for Algebra 1, the equation of a line, is a polynomial function. It's a polynomial function of degree 1. Now, a polynomial function is just a sum of monomials, terms that have a number and variable or product of the two, and have exponents. Now, this here is just the general form of any polynomial function of degree n, because n just is a number. So we could say 6. So we could say that this here is x to the 6. The next one is x to the n minus 1. Well, 6 minus 1 is 5. And we just continue on. So n minus 2. So 6 minus 2 would be 4. Then we would have n minus 3. So 6 minus 3 would be 3. And continuing on till we get x to the first and then x to the 0. The a sub n, the one in blue, is just a number in front of x. A sub n minus 1, just either the same number or a different number. It's just a way to write this in general for any and all polynomial functions. Now, when the degree is 0, it's a constant term. So like f of x equals 14. It's just a number. Now, if the degree is 1, it means the variable with the biggest exponent is just x to the first, which is a linear function, an equation of a line. Now, when the degree is 2, we just covered that in our last chapter, is our quadratics. So 2x squared plus x minus 9 is an example of a quadratic. We can have a degree 3, which is a cubic. That means the variable with the biggest exponent is x to the third. And we can have a quartic, where the degree is 4, x is to the 4th power. Questions on this so far? Now, we consider a polynomial function to be in standard form when we rewrite it or writing the polynomial in order of descending or decreasing degree from highest to lowest. That means the variable with the biggest exponent goes first, second biggest goes second, and so on, going on down to the constant term. And the leading coefficient is the number in front of the variable with the biggest exponent. The number in front of the variable with the biggest exponent is the leading coefficient. Questions on any of this so far? Okay. Now, we need to be able to classify what a polynomial function is. And in most cases, it's easier to classify what it's not than what it is. And especially if you're trying to describe what something is or classify something, it's easier to describe what it's not than what it is half the time, especially if you're not familiar with it. So one of the first things we can say that a polynomial function will not have is it can't have negative exponents. It cannot have a negative exponent. So we can't have x to the negative 2. We cannot have a negative in the exponent. Exponents aren't fractions. So we can't say x to the 2/3. We cannot have fractional exponents. We can't have a variable inside of a radical. So what we're talking about here is square roots, cubed roots, fifth roots. Or the 9th root of 3x. We cannot have a variable inside of a radical. Questions on this so far? Next one. Almost. Let's try it again. Variables aren't multiplied together. We can't have two different variables multiplied together. So we can't have two variables being multiplied together. Variables can't be in the bottom of a fraction. Because if a variable is in the bottom of a fraction, we actually call that a rational function. We do have one more that I do need to add. Variables can't be in a variables can't be in an exponent. Variables cannot be in an exponent. And what we're talking about this here, this 3 to the x. This is actually considered an exponential function. questions on this so far? Okay. Let's look at the first one here. So first off, we need to decide whether or not it is a polynomial function. So if we look at a, negative 2x to the third plus 5x plus 8, does it have a variable and an exponent? Well, no, there's no variables and exponents, are there? Is any of the exponents negative? Are any of the variables fractional? Do we have a fraction and an exponent? Do we have a variable inside of a radical? No. Do we have any variables being multiplied together, two different ones? No. Do we have a variable in the bottom of a fraction? So can we say this is a polynomial function? Yes. Okay. So this is a polynomial function. So if so, write in standard form, state its degree, type, and leading coefficient. So standard form means that we are writing it from biggest exponent to smallest. So what is the biggest exponent in this here? 3. So negative 2x to the third would be the term with the biggest exponent, yes? Is it first? Yeah. So the next exponent after it would be 2, but we don't have a term with the power of 2. So the one after that is 1. Is it next? Because the next smallest power is x to the first. So is it next? And lastly, we have 8. So is this already in standard form? Yes. Okay. So it's in standard form. So now we need to determine what the degree is. And what is the degree of this? Well, the degree is the biggest exponent. So what is the biggest exponent? So degree 3, we have a specific type, we have a specific name we call it, and it would be cubic. A degree 3 is a cubic function. And we do have a chart on our first page of the note sheet. Now the last thing is the leading coefficient. Now what is the leading coefficient for this here? What did we define leading coefficient as? As it was on the first page. Leading coefficient? The number in front of the term with the highest power, the number in front of the variable with the highest power. And what is the number in front of the variable with the biggest power? Almost. Negative 2, we'll take the sign with it. So the leading coefficient's negative 2. That's it. Questions on this here? And that's all we have to do for this here. Let's look at B. So we need to determine if it is a polynomial function. So do we have a variable and an exponent? No. Do we have negative exponents? Well, our exponents are 3 and 4, so there's not a negative exponent. Are there fractional exponents? No. Variables inside of radicals. So we're looking at this one here, yes? Does that radical contain the 2 or the 2 and x to the fourth? It's just the 2. The bar doesn't go all the way over. So if it did, if it came all the way over here, then yes, those are both included in a radical. But we don't have that. We just have it over the 2. So no, we don't have a variable inside of a radical. We don't have variables multiplied together, two different ones. And we don't have a variable in the bottom of a fraction. So can we say this is a polynomial function? Yeah. Is it in standard form? Because what's our biggest variable? Variable with the biggest exponent? The x to the fourth. So it needs to go. So we would say the square root of 2 times x to the fourth. What would be our next term? 0.8 x cubed, yes? And it would be subtracted minus, what's our next term? minus 12. Because we'd have the fourth power would go first, so it's the biggest, then the third, second, first, 0, our constant term. But if we don't have them, we don't need to include them. So we're just decreasing powers. And we could call this g of x because that's how they denoted it. Now what's our degree? 4, it's the biggest exponent. Type. It is quartic. Quartic. Leading coefficient. Square root of 2. Because it's just the number in front of the variable with the biggest exponent. Questions on this so far? We ready to look at C? Does it have a variable and an exponent? Does it have a negative exponent? Yes. Does this middle term x to the negative 1? So is this a polynomial function? No. Do we need to state the degree, put it in standard form? Any of that? No. We only have to do that if it is a polynomial function. Let's move on to the next one. Is it a polynomial function? Why not? Variables can't be in an exponent. No. Questions on this here? Let's look at the next one. So we can look at number 1. 7 minus 1.6x squared minus 5x. Can we say this is a polynomial function? Because it doesn't have a variable in the exponent. We don't have negative exponents. We don't have fractional exponents. We don't have a variable inside of a radical. We don't have two variables being multiplied together. And well, we don't have fractions in general. There's no variable in the bottom of a fraction. So yes, this is a polynomial function. Is it in standard form? So how would we write it in standard form? Negative 1.6x squared, negative, then plus 7. So that would be standard form because we need it in decreasing powers for the variables. Degree is what? Type. So power 2 is not linear. It is a quadratic. And lastly, leading coefficient, negative 1.6. Questions on this here? And if you're wondering, yes, I do. I have this on the test. Now, the next one, can we say it is a polynomial function? No. Because we have x to the negative 2. Number 3, is it a polynomial function? Yes. If we go through the entire checklist, it does not check off any of those. Now, is it in standard form? So how would we rewrite it in standard form? Fourth plus x cubed minus 6x. The degree is 4, which means its type is quartic, and the leading coefficient, 3. Just the 3. Yep, leading coefficient, we're just wanting the number. Any questions on any of this here? We've liked this stuff so far, which means the next part's probably going to be difficult, yes? Okay. Evaluate f of x equals 2x to the fourth minus 8x squared plus 5x minus 7 for when x is 3. Yeah, we can say 2 times 3 to the fourth minus 8 times 3 squared plus 5 times 3 minus 7. And again, we're plugging this in. We're just evaluating for when x is 3. So on the calculator, we can do 2 times 3 to the fourth minus 8 times 3 squared plus 5 times 3 minus 7. And we get 98. Which one? I call it the little caret key. Now you do need to be careful with the caret key, that exponent key, because it will keep it up in the exponent. It won't immediately drop it back down. So if you don't hit the left or your right arrow after you put the number in, it will continue to type everything in the exponent. Now, at this point, you've been told multiple times to not type the variables in. Because the yellow calculator, you probably noticed in middle school that they had it there. And your middle school teachers told you do not use those as that. Because this here, that's not what we're talking about. Because when we try to factor or do anything with that, we're not talking about x as a number. We're talking about it as a variable. And both these calculators need it as a number, yes? It needs a number. In this case, what were we saying x was? 3. Now, you've probably seen this number, or this here, it's on both calculators, STO. The yellow calculators have it too. It's above the on button, I believe. That stands for store. So what I can do is I can hit store, X, enter. And now if I hit X, I store the value of 3. I have defined X as 3 in the calculator. So what I can say now is 2x to the fourth minus 8x squared plus 5x minus 7. Because we've already found out what it is. It is 98, yes? Now again, with negative numbers, because again we have to make sure we put the parentheses around it, because a negative number to an even power should be positive. Here, I could say negative 2 store x, enter, enter. Storing is an easy way to calculate multiple numbers for the same function, as it'll just do it. Both of the calculators will do it. But you do need to be careful to make sure you store the number in correctly, or it's the correct number you're wanting to use. Questions on this here? Let's look at the next problem. Negative 2x to the fourth plus 6x cubed minus 3x plus 11. So we could say negative 2 times 4 to the fourth plus 6 times 4 to the third minus 3 times 4. So we're just typing it in. And we get negative 129. Or I could say 4 store x, so negative 2x to the fourth plus 6x to the third minus 3x plus 11, enter. We get the exact same thing. Questions on this here? Because again, on these here, we're just plugging in that value for x, yes? Questions on anything we've done so far? Now, we'll look at one more of these. I want to look at the next one, the negative x cubed plus 3x squared plus 9, yes? I'm going to graph this one. Negative x to the third plus 3x squared plus 9. This is the function, yes? I can hit graph. Well, let's look at the table. Now, it wanted us to evaluate it when x is 4, yes? On the table, when x is 4, the y value is. So if I plugged 4 into the function, I would get a value of, because when we graph something, we plug the x value in and see what the y value is, what the output is. When we evaluate, we're doing the exact same thing. Any of those methods work for these here. Questions on any of this so far? We have one last thing we're talking about today. In behavior. In behavior of a function talks about what the ends of the function will do eventually. Now, when we looked at the quadratic functions, we looked at the graph, they both either went up or they both went down, yes? And that works for any quadratic. It's either both sides are going to go up or both sides are going to go down. Now, that works with any even degree. So when we have these polynomial functions, they're going to eventually behave in one of 4 ways. Now, we're either going to have the degree is odd or the degree is going to be even. So the degree is either odd or even. The biggest exponent is going to be odd or even. We only have 2 choices. Because it's either going to be an odd number, 1, 3, 5, 7, 9, 13, 15, going on, or it's even, 2, 4, 6, 8, 10, 12. There's only one number that's neither odd nor even, odd or even, 0. But if the degree is 0, we're talking about a straight line. Because that was one of the first ones we had on the chart. It was a constant function, it's a line. It's just going to go flatline. It doesn't go anywhere. So, in any of these polynomial functions, the degree is going to be either odd or even. The leading coefficient's either going to be positive, or the leading coefficient's going to be negative. Now, for even degree functions, the y values, the f of x values, are either both going to go up or they're both going to go down. Now, the way we describe this is f of x approaches infinity, positive infinity, as x approaches positive infinity for even and positive. So what that's saying, even and positive, here, as x approaches infinity, as we get bigger and bigger values of x, the y values are going up. And as we get smaller and smaller values of x, as x approaches negative infinity, the y values are still going up. So we define it as f of x approaches positive infinity as x approaches positive infinity. And f of x approaches positive infinity as x approaches negative infinity. Now for even and negative, f of x approaches negative infinity as x approaches positive infinity. And f of x approaches negative infinity as x approaches negative infinity. Now, odd functions we haven't talked too much about, because the main odd function that you've talked about is a great straight line. Guys, straight line, degree 1. Because for linear functions, we either had them going like this here or this here. But if you notice the y values are either going, one's negative, one's positive, or one's positive, one's negative. And that works for any odd degree functions. So when we look at this here for our standard notation, f of x is going to approach positive infinity as x approaches positive infinity when it's odd and positive. And then f of x is going to approach negative infinity as x approaches negative infinity. And for the last one, f of x approaches positive infinity as x approaches negative infinity, and f of x approaches negative infinity as x approaches positive infinity. Because they're going to go in opposite directions. And this kind of dot, dot, dot line is depending on the function and the numbers that go with it, it will behave differently between those two. But eventually, for odd degrees, they're going to go in opposite directions. They're eventually going to go off in opposite directions if its degree is odd. If the degree is even, eventually they will both end up going either both up or both down. And this is helpful, especially when we start graphing. Now, let's look at this here. We want to describe the end behavior of this function. Now, looking at this here, the degree is what? What is the degree for this function here? 4. And 4 would be even. Leading coefficient, because these are the two things we need for end behavior, is degree and leading coefficient. And the leading coefficient for this is what? Negative 0.5, so it would be negative, yes? We can, but the final answer for this here is, again, I'll look back at the chart that you have written there too, yes? If it's odd behavior and negative, even degree and negative, well, we're saying f of x approaches positive infinity as x approaches, not positive, sorry, because I keep wanting to do positive, but f of x would approach negative infinity because, again, for even and negative, they're both going down. So it approaches negative infinity as x approaches positive infinity. And f of x approaches negative infinity as x approaches negative infinity. Now, one of the things for any of these here, x approaches positive infinity, x approaches negative infinity, will be in every answer. The second part. And what really changes is our f of x, what it's approaching. Because if it's even, they're both going to go to the same thing. Either both go to positive or both go to negative. If it's odd, one's going to positive, one's going to negative every time. That's it. That is the answer. There's nothing else to it. Questions on this here? Let's look at the next one here. The degree is 3, so it is odd. So this is negative. So f of x approaches, so negative and odd, so they're going in opposite directions, yes? So one of these is going to approach positive infinity, and one of the f of x's is going to approach negative infinity. Now, so they're going in opposite directions. So since it's odd and negative, it's going to approach negative infinity as x approaches, negative infinity as x approaches positive infinity. And f of x is going to approach positive infinity as x approaches negative infinity. Really, that's saying that it's going to the left and up, and it's going to the right and down. Now, yes, we can type this into the calculator. The calculator won't give us this answer directly in this form. It'll show it to us, but it won't give it to us. Because what we can do is I can grab the graphing calculator and type it in, negative 0.3 x to the third plus 1.7 x squared minus 4x plus 6. I hit graph. So we can see here as we go towards the left side of the screen, it is going up, yes? As we go to the right, it's going down. And it'll do that way every single time. Questions on this here? Let's look at one last one. So for in behavior, the degree for this is 3. So it is odd. Leading coefficient 0.25, 0.25, which is positive. F of x, since it's positive, is going to go to positive infinity. And f of x is going to go to so for this here, and we can look at the chart, so odd and positive, f of x approaches positive infinity as x approaches positive infinity. And f of x approaches negative infinity as x approaches negative infinity. Questions on any of this here? A lot of this is just following the chart and matching it up. So I'm going to say this here is our graph screen, yes? Now this, most likely, what I'm going to put down is not necessarily the graph itself. I'm just going to draw one. And if we had something like this here as our graph, what do I know about it? Because what did we say this is? F of x approaches positive infinity as we go to positive infinity, yes? As we go to the right, this function is going to go where? Up, yes? So it means somewhere over here, this function should go back up, yes? And we talked about quadratics for solving by graphing. We solved it where it crossed the x-axis, yes? Which means somewhere over here, I should have another solution. It gives me an idea of what the graph's doing, where solution should be. But that's the end of 4.1. If I do include it. Yeah. 3 through 6, 9 through 14, 17 through 19. 9 and 10 are error detection, error correction. So you need to describe and correct it. You need both parts. If you don't include both parts, I will take off half. Because there is a problem with them and you need to fix it. F is a polynomial function, the degree is 3, and f is a cubic function, the leading coefficient is 8. So figure out what is wrong with their statement and fix it.